Let's take a look at the molecular geometry of ammonia. The central atom is nitrogen, and nitrogen shows up a lot in biological molecules. And if we take a look at the valence electrons of nitrogen, there are five, one of which is a pair, three unpaired electrons. So nitrogen tends to form molecules where there is a lone pair on the nitrogen and then three bonds. So ammonia is the simplest molecule made of nitrogen and hydrogen. So we'll use it to start our discussion. Looking at nitrogen, it has four electron pairs in ammonia. One is a lone pair, and the other three are bonding pairs. These four electron pairs want to be as far apart as possible, so they assume a tetrahedral arrangement. Now, because there are only three atoms, however, the molecular geometry of ammonia is not tetrahedral. The molecular geometry of ammonia is trigonal pyramidal. And that is because when we determine the geometry of a molecule, all we care about is where the atoms are. So if we look at this ball and stick model, we can clearly see this is a trigonal pyramid. Trigonal meaning there are three kind of feet to this tripod, and pyramid because it's three-dimensional. This nitrogen is above the 3 feet of the hydrogen in this tripod. Now, it's important to know that the lone pair is there, even though we don't show it in our molecular ball and stick model, because that lone pair still repels, and it actually repels more effectively than the bonding electrons. So when we look at the bond angles in ammonia, they are actually less than 109.5 because this lone pair is more effective at repelling. So what I want you to know is when there is an atom that has four electron pairs and one of them is a lone pair, the geometry is going to be trigonal pyramidal and the bond angles will be less than 109.5.